While desperately waiting for the GTA 6 release, I decided to replay the GTA 5 story one more time. During my playthrough, something unexpected happened. I was captivated by the character switching effect, which I completely overlooked for years. It felt so seamless, so perfect. I just couldn't help but wonder, how did Rockstar pull this off? I couldn't stop thinking about it. I had to recreate it myself. 3 weeks later, I'm here to share what I uncovered, and trust me, there's so much more to this effect than it looks. But you know what? Don't trust me. See it for yourself. Let's start with an overview of the whole effect. When the player triggers the character switch button, UI elements appear on the screen, allowing the player to choose their next character. Then, when the player triggers the character transition, the main effect starts. It consists of a couple of camera transitions that zoom out of the current area, followed by a couple of zoom-in camera transitions at the location of the next character. The whole switch goes without any loading screens, interruptions or pauses, no matter where the characters are on the map. This blew my mind back in 2013 when I first used it, since there was no other game that provided transitions at such a scale without any loading screens. Also, the effect gets even more impressive when you realize it ran on PS3 hardware. I could talk about it for hours, but let's take a more detailed look instead. First, when I press the Alt key, notice how the screen gets a little bit darker. The colors become dull, and the edges of the screen get even more darker than the center of the screen. This effect remains until I select the next character. Then, when I confirm my selection, the main effect starts. The UI elements immediately disappear, and the look of the game drastically changes. The first and most noticeable thing is that the main color of the current character covers the entire screen. Also, everything seems a bit blurry. Next, there are some noticeable color shifts and distortions happening at the edges of the screen. And finally, the contrast between the bright and dark areas is much more pronounced. As the camera starts moving about the player, all effects seems to fade out. Well, all except the darkening of the screen edges and the main character color overlay. Wow, that's a lot to take in, and we've only scratched the surface of the effect. But let's see how we can recreate this part before we continue with the analysis. Unity has a built-in post-processing stack that could be used to recreate these effects, but I wanted to create them manually to gain a deeper understanding of how they work. Since all these effects appear over the whole screen, they must be image effects. To reproduce them, I've quickly set up a custom full-screen render feature that passes the current camera color texture through a custom material to modify its look. For the first modification, let's start with the simplest one, applying the character color to the whole screen. To do that, I just multiply the character color with the current color of each pixel. To control the intensity of the character color, I interpolate between the original pixel color and the one tinted with the character color. And here's the result. It's quite a big change to the look of the game, caused by such a simple shader instruction. And if I change the intensity of the color, the overall look changes accordingly. The reason I've added this color intensity control is that whenever the camera switches to a higher position, the impact of the character color is reduced. This provides an additional feel that we're getting further away from the current character. Then, when we start zooming in to the next character, the character color intensifies again. With the character color effect applied, the next strong effect I always notice during the transition is the image distortion at the edge of the screen. I've started researching how to apply distortion in shaders and stumbled upon this article from Harry Alisavakis. He explains that for applying distortion to the image, all we need to do is offset the UV coordinates at which the texture will be sampled. If we specify the offset via special mask texture, where the whiteness of a pixel determines the strength of the offset, we can get very interesting results. Even though the distortion resembles an elliptic shape, I wanted to start simple and create a circular shape distortion first. I calculated the distance of each pixel from the center of the screen with the idea of using that distance as an offset for UV coordinates. I expected to get a circular result, but the result resembled an ellipse due to the aspect ratio of the screen. I wasn't expecting this, and I rarely get positive surprises like this, So I implemented a small smoothing for the distance calculation and decided it was good enough. And here's the final result of the distortion. The edges of the screen are nicely distorted, just like in the original effect. Oops! And this was trippy. I guess I just need to constrain the distortion intensity values to prevent this from happening. Awesome. This next part of the effect was quite difficult to spot. Take a look at the edges of the screen again. Can you see it? When the distortion happens, the individual color components of the pixels seem to spread out, providing this rainbow edge. This effect is known as chromatic aberration and happens in reality due to failure of a lens to focus all color channels at the same point. Some people like this effect, others don't, so you should always keep an option in settings to disable it. When it comes to implementation, it's really simple. All we have to do is sample the camera color texture 3 times, once for each color channel. The trick is though to sample each color channel with a small offset. Here, I've calculated the offset based on the pixel's distance and direction from the center of the screen. And here's how it looks. When I increase the multiplier for the offset of each color channel, the edges of the screen start to have these rainbowy outlines. Everything is shaping up nicely already, but we still have a couple of things to add. If you remember from our initial analysis, the contrast between the bright and dark areas gets really exaggerated when the effect starts. Also, the bright areas start to shine much brighter than before. These kinds of changes in the look of the image fall in the category of color grading. To be honest, they can get really complex really fast. I'm a really hard worker, but this seems like too much work. Is there another way? I started exploring color grading theory and reading different articles. After a couple of hours, I found this article about the usage and power of lookup textures. Here's the basic idea behind them. You create this trippy texture and apply advanced color grading effects to it. Then, during gameplay, you use your current color of the pixel as a key to find a matching adjustment color from the lookup texture. And here's how I implemented them. First, I created a neutral lookup texture by combining multiple linear gradients distributed in different directions for each color channel. When you combine those individual linear gradients of each color channel inside of a single texture, you get this funky looking image. You can do that in some image editing tool, but I've decided to implement it in a script. I just go over every color channel in a for loop and output the interpolated color value to the texture. Since no special color effects have been added to this texture yet, applying this neutral lookup texture over the screen should give exactly the same result. Nothing should change. Let's give it a quick test to confirm that it's working. What? Okay. I forgot to remove the sRGB checkmark for the texture since all channels are in the linear range from 0 to 1. Let's see how it looks now. Well, is this an improvement? Maybe? There's something else still going on here. After checking the code multiple times and trying out different settings, I finally got to the root of the issue. I've left the mipmap generation enabled. This creates multiple smaller versions of the texture and affects the texture sampling, which, of course, is completely unnecessary for image effects. There we go. Finally, we're correctly color grading the image with the lookup texture. I mean, we're still not adjusting any colors, so let's change that. To add color grading effects to the lookup texture, I imported a screenshot of the game to Photoshop and applied different color adjustments to it until it started to look close to the screenshot of the game during the character transition. Then I copied all adjustments and pasted them over the neutral lookup texture. You can see the difference between the original one and the one containing adjustments. Then I imported this adjusted lookup texture in Unity and assigned it to the material. And this is the result. By interpolating between the original color and the adjusted one, I can control the intensity of the color grading. And let's see how all the effects look together. This is starting to look really good. There's one final thing left to add: the blurriness and leaking of the light around bright areas. This effect is commonly known as the bloom. It's basically a blurring filter applied over the image but only visible around the bright areas with high luminosity. The way this effect works is by filtering the camera color for bright areas and then applying a bunch of blur render passes that will effectively smudge those bright areas. This effect requires quite a lot of work to implement, but I was confident that I could do it. First, I expanded the render pass with additional render textures that will hold the intermediate blurring results. Note that for every sequential blur pass, the texture size is reduced in half. Then, I added those additional render passes that will apply blur to the camera color. Finally, I've added the sampling of the bloom texture and applied its effect over the camera color to the main character transition shader. Let's see how this works in action. First, I filtered the image for the bright areas since the blur should only be visible around them. Then, through several render passes, I applied the vertical and horizontal blurring to the image. Finally, I apply light scattering by controlling the impact of the lower and high resolution images when merging them together. The result is exposed as a bloom texture to the main character transition effect. And this is how it looks in the final image. I can control how much it should affect the final look by controlling its intensity. And if we combine everything we've implemented so far, this is what we get. I'm really happy with how everything is looking so far. At least how it looks in this static form. Let's examine how they behave during the transition. When the transition is triggered, the effects are at their full intensity. Then, as the camera moves above the player, they slowly fade out. The only things that remain are the character color and a bit of darkening around the edges. Then, the camera instantly transitions to a higher position, and the effects are applied at full intensity again. The only noticeable difference is that the character color effect is reduced a bit at this camera height. Then, as the camera slowly moves upwards, the effects are gradually reduced. This whole process is repeated 3 times until the camera is at maximum height and there is no character color applied over the view. Then, the camera starts animating towards the position of the next character. When it reaches the position of the next character, everything is repeated. The camera instantly moves to a lower location, then starts slightly moving downwards while the effects fade out. With each iteration, the color of the next character gets stronger and stronger. Finally, after the camera teleports just above the character, it slowly animates to the height of the character while the effects slowly decrease. Well, this was a handful, but let's get down to work. Developing a robust camera system from scratch would be a lot of work. Luckily, Unity already has a built-in camera system in the form of a Scene Machine package. It's really powerful and enables a lot of different functionalities, but the main one I need is the use of virtual cameras. These aren't actual cameras, they're just placeholders indicating different camera shots. By activating a certain virtual camera, the actual camera will start changing its position, rotation and lens properties to match the ones of the virtual camera. Also, I can specify the details of each transition between specific virtual cameras. For example, I can specify the transition duration of 0.6 seconds between the camera that follows the player and the one vertically above the player. Then, when I trigger the transition, the camera will animate toward the vertical position in 0.6 seconds. Pretty neat, right? After specifying all the required virtual cameras and transitions between them, we get something like this. Now, let's add visual effects on top of each camera transition. For that, I've implemented this animatable shader property structure that contains data for animating one shader property over time. Then, I've added all properties that can be animated into a scriptable object so that I can specify which properties should change for which camera transition. Finally, I've implemented a simple controller that will guide this whole transition. Its only job is to control the execution of camera animations and effect transitions. With everything in place, let's check how this effect is currently looking. Damn, this already feels really good. Even though we're not actually transitioning to a different character and location. Rockstar really knows what they're doing. After testing the effect in different parts of the map, I decided it was time to add multiple characters that I could switch between. Conveniently, Unity has a package of 3 characters from the Atom project. I've imported them into the project, took their mugshots, and save them as textures. Also, I've quickly set up this little example UI picker so that I can pick between different characters. For this, I've created a full circle, circle outline, and gradient circle textures in Photoshop. They're all white so that I can programmatically color them based on the color of each character. And here's how the UI looks in action. When I press and hold the Alt key, the UI shows and I can use the mouse to select between the characters. Neat. However, in GTA 5, when you trigger the character selection button, the environment gets a bit darker on the edges of the screen and the colors get a bit desaturated and dull. This effect lasts until you change the character or decide to cancel the transition. Let's start with color desaturation since I've already implemented color grading for the camera transition. If you remember, I've created this neutral lookup texture that I can use as a base for applying different color grading effects. Again, I imported the screenshot from the game to Photoshop and applied different adjustments to it until I got something that resembles the one from the GTA 5. Then, I copied all adjustments and pasted them on the neutral lookup texture. Finally, I've imported the result back into Unity and applied it to the screen when the UI is active. What? Not again. Oh yeah, I forgot to remove the sRGB and generate mipmaps checkmarks again. Oops. Much better. With the environment colors desaturated, the UI pops out into focus even more. Awesome. The last thing left to do regarding the UI setup is to apply this darkening to the edges of the screen. When the edges of the screen are darkened, our eyes are automatically drawn toward the center of the screen. This kind of darkening, visible only at the edges of the screen, is known as the vignette effect. It's often used to give a camera shot a more dramatic feel or to direct the user's attention toward the center of the screen. The implementation is really simple. I get the distance of the pixel from the edge of the screen and interpolate the pixel color towards black based on that distance. The further away the pixel is from the center, the stronger the effect of the black color. Additionally, I've implemented a small smoothing to the distance calculation so that the change is less linear. I've also added the multiplier that will control the intensity of the effect. Let's see how this looks. This is the regular camera shot of the scene. When I crank up the intensity of the vignette effect, you can see how the edges of the screen gets darker and darker. Sweet. And this is how it looks when applied to the character selection UI. This looks so much better. With the UI completed, let's check the current state of the transition. When I press the Alt key, the UI appears and the environment becomes desaturated with the vignette effect appearing at the edges of the screen. While the UI is active, I can switch between characters with the mouse. And when I click on the character I want to switch into, the transition starts. The camera transitions multiple times to higher locations, animating the post-processing effects along the way. Then, it moves towards the location of the selected character, and the whole process is reversed. Finally, after the transition completes, I get control of this new character. Well, this looks really good to me, but let's check the original effect to see if something is missing. Oh, I see something I completely overlooked. Did you spot it? It's visible during the quick camera transitions, but it's clearly visible after the camera moves to a different location. Did you see it now? It may be hard to spot on YouTube, but during the whole transition there seems to be some flickering of the individual pixels. It looks like artifacts from old photographs or films. After some investigation, I learned that this kind of effect is known as film grain. It was originally caused by small chemical particles that were used during the creation of photographs or films. To simulate such an effect, we could calculate a random value between 0 and 1 for each pixel and then darken it based on that value. However, complete randomization never really looks good, and the film grain is no exception. To make it look more realistic, the effect should be less visible in very dark or very bright areas of the image. To determine whether a pixel is bright or dark, we need to calculate its luminosity. This is really simple and is already available in Unity inside the color.hlsl file. Now, when we know how bright the pixel is, we can control the intensity of the film grain effect for that pixel. Also, to avoid complete randomization of values, I've created this film grain texture in Photoshop, which I then scale and offset at runtime to provide a change of values. And this is how it looks when applied to the image. I really like it. With that, let's see how everything looks all together. I gotta say, I'm quite happy with how this turned out. And I'm actually quite thrilled that I've managed to recreate it in a reasonable time frame. Well, actually, the effect isn't complete just yet. While I was testing transitions between these two characters that were quite close to each other, I noticed that it was really silly that the camera needed to move all the way up just to move all the way down at the same location. I can't remember anything like that from the original game, so I've decided to give it a test and see how Rockstar handled it. But before I show you, do you remember how they did it? Pause the video here and leave a comment on how you think they've handled this edge case. It turns out they've implemented a different looking transition just for this situation when the characters are really close to each other. The camera doesn't move above the player and doesn't transition to higher locations. Instead, the transition is quick and smooth and allows for quick switching between different characters that are close to each other. Really cool. This intrigued me, so I wanted to test at which point this short distance character switch transitions into the one used when characters are far apart. After a bit of testing, I found out that it happens when the distance between characters is about the distance of one city block. However, the resulting transition wasn't the one I was expecting. It was actually its shortened version that had only one camera transition to a higher location before moving the camera and zooming into the next character. Wow, I wasn't even aware that this shortened transition form existed. Nice work, Rockstar. Luckily, we already have everything we need to implement these shortened transition versions. I quickly specified the camera transitions and post-processing effects that will be used for each transition variation. All that was left to do was to implement a simple distance check between characters to determine which type of transition I should use. And let's see how this looks in action. When I select the character close to this one, the short transition is selected and I'm in immediate control of the selected character. But if I select a character that is further away, a longer variation of transition will occur. Awesome. Even though the effect looks visually appealing, it feels a bit empty without sound effects. However, I'm no sound engineer, so I had to steal audio from the original game by screen recording gameplay and cutting out small audio segments. Back in the engine, I added the logic to play the appropriate sound effect at the correct time in the transition by subscribing to events raised by the transition controllers. And here's how everything turned out. Even though I'm happy with how the final effect turned out, there are many additional things happening behind the scenes in the original effect. For example, hiding cars and pedestrians during the zoom out phase of the transition, loading in data for the part of the map where the next character is located, and reducing details on models further away from the camera so that they can be rendered on PS3 in real time. They are all invisible in the final effect, but are essential to its successful execution. However, they are also really complex topics on their own and, as such, fall way out of scope of this video. I just wanted to highlight them since Rockstar really had to dance around the hardware boundaries to achieve this effect. Also, they've added an additional bit of polish to this whole transition by adding special cinematic sequences that would play at the end of the character transition. They're often humorous and match the personalities and surroundings of each character. I really like them. Now, if you really like our videos and want to support us so that we can make even more videos, consider checking our Patreon account. There, you can gain access to the project files or take a look at additional detailed technical breakdowns of the effects. You can even give us a suggestion on what you would like to see next. That's it for this one. Thank you for your time and I'll see you in the next one.